Okay, can you hear me? Thanks, Abe, and thank you all for being here. The topic of the talk of today is going to be action prediction from textual descriptions of scenes. So probably you have heard before about action prediction, but in the context of computer vision. So here usually we have a video and we have some previous frames, maybe from 1 second before, 5 seconds before, and we have to predict what is the upcoming action that is about to happen. For example, in these frames, we can see that we can predict a kiss in the first case, a high five, or a hug. So when we are doing this in computer vision, we care about the local information that we see in the frames, but it's also likely to be possible that you also can predict better if we have background, because, for example, we have watched the show. So all this information can be useful. The point here was it's possible to do this, but instead of using visual descriptions of scenes, using textual ones. So if we want to do this, we want our dataset to have a set of properties. First, we would like to be real natural language sentences or documents where ideally it should be written by many users with different styles and domains, so we can mitigate the effect of potential biases. And also, if we want to label those texts with actions, we want the actions to be as unambiguous as possible, so we can create a high-quality dataset. And ideally, if we don't have enough money, for example, to get humans to annotate the text, we want to annotate them in an automatic way, but still we want it to be reliable. So in this work, what we thought is that we can use Harry Potter books as a testbed for action prediction. So as you probably know, Harry Potter books happens in a fantasy world where they define a set of spells. And spells are nothing else but magical actions that are used as a response to an environment when it's happening a very specific situation. And it's used with a very specific purpose. So, for example, we have Lumos that is used to light a dark space. We could think of many others, like, for example, Avada Kedavra to kill a target, or Alohomora, right, to unlock or open a door. So how does this look when we want to map this to textual descriptions? So basically the idea is that we are going to have a paragraph where at the end we are going to be casting a spell, in this case Alohomora, and inside that paragraph we will find some sentences that are relevant to predict it. For example, in this case, we can see that they are in yellow, they slam into a door, and it was locked. They pass helplessly, Hermione snarled, she grabbed Harry's wand and tapped the lock. So this is giving us information about the spell that is going to happen. So to create our data set, what we first thought was about using the Harry Potter books. But unfortunately, if you go there, you will find that there is just a few hundreds of occurrences of spells. So if we want to test like machine learning models, this is not going to be possible. So instead, what we thought next was to use fan fiction. And the good news about fan fiction is that there are thousands of documents where there's going to be thousands of occurrences of spells. There are many uses right in there, so we have our variety of styles and topics. And also, we have crawlers that are available that we can use to download it. It's also fair to say that when we are creating a data set in an automatic way, there is also some limitations. For example, in this particular case, we are working on a fictional domain, so it's hard to map to a real application. It's more like a toy problem. And there is also some issues that might happen with automatic annotation. For example, when we are working with literature, we have to take into account that surprise parallel plays a role. So we cannot always expect that a character is going to cast the most obvious spell at each time. There might be also some possible texts that are labeled incorrectly, for example, like an occurrence of the spell that might be just describing what the spell is about. And then we also have to think about toxic content that might be in fan fiction, like, for example, erotic content. But in summary, our corpus has 85 different actions, and it's more than 80,000 samples for training. So here, the thing that we have to decide now is what is the context that we are considering to try to predict a spell given a sample. Ideally, we will have to like all the previous texts or even other documents so we can have all the knowledge. But in this paper, we follow a more simple approach. And basically, what we are taking is the snippets with the 32, 64, 96, and 128 previous tokens before the occurrence of the spell. And in most of cases, there are some actions that are more frequent than others, so it's an unbalanced data set. So what's the problem about taking shorter snippets? So if we go to our example that we saw before, in this case, if we take a shorter snippet, we only have one relevant sentence. That is, Hermione snarled, she grabbed Harry's wand and tapped the lock. The problem with this is that we cannot know if Hermione wants to unlock or lock the door. So for that, we need longer context, as we were saying before. What about the models that we tried? Basically, we have addressed the task as a sequence classification problem. So basically, the input is going to be a sequence, and the output is going to be a label labeling the sentence. And with respect to the models, we are not trying anything very fancy, just generic approaches that are commonly used in many natural language processing tasks, like logistic regression or a multi-line perceptron, LSTMs, and CNNs. And we are going to average the results across 5 different runs. So if we compute the experiments, here are the results for the different snippet lengths. And for the 4 models that we have considered, we can see that there is no clear difference with respect to the F-score. But what it looks like is like the LSTM is able to take more advantage of longer context, which is not surprised because it's specifically designed for that. However, if we just look at these results, it's not like we can get a lot of understanding of what is going on or what the models are learning. So a way to know a bit more about them is to compute instead recall at X. We did that with the longer context that we tried, 128 tokens. And here we start to see more interesting things. Like, for example, the recall at 1 is not really very good, but on the other side, it rapidly increases. And for example, with recall at 10, it's almost 80%. So what this tells us is that even these models are not able to completely discriminate the action in the first place. They are getting a sense of what is really going on in a given paragraph. If we split the results by frequent and infrequent actions, frequent was every action that was above the average. We also see some interesting tendencies, like as expected, frequent elements are easier to classify. But in both cases, when the recall helps to increase the performance. What about misclassifications? So what we observe is that many misclassifications actually correspond to related actions or counteractions of the spells. So for example, there is one spell in the corpus that is Coloportus, that means to close a door, and more than 1/3 of the misclassifications went to the counteraction that was Alohomora. The same happens with Nox, that it means to extinguish the light from a wand, and we saw that most of the misclassifications went to Lumos, that it's again the counteraction that means to light a darker space with a wand. And we also observe that some misclassifications went to semantically related actions, like it's the case of Omenum Rebellion, that means to rebel human presence, and was again misclassified at the Lumos. So in both cases, these actions means they are trying to reveal something. So also related to this, what we observe that the spells that are intended for very specific purpose tend to obtain a much better F-score. Like, for example, spells that deal with a very specific with a specific magical creature, they tend to obtain better F-score than more general actions. So what are the takeaways of this paper? So basically, we have used Harry Potter fan fiction as a testbed. for action prediction from textual descriptions of scenes, and we extract this from fan fiction stories of fans. We have used spells as keywords that help to extract actions, and then we test generic sequence classification models to try to predict them. And as future work, what we think is that if maybe this is just language modeling, where the output vocabulary could be restricted to a given set of words, or if it could be a problem where BERT and other Muppets could help. And I think that's all. I will be happy to take any questions. Well, it will be hard to enumerate them all, but for example, these ones like open the door or light the space, I think they will be, we could easily map them to things like turn off the light or something like that. And even if you want to kill someone, or there are other spells that means to, if you want to hurt someone or want to ask someone to tell the truth, you have all this kind of stuff. So I guess you could have somehow map to real actions, but there are some other, like for example, these that try to fight like magical creatures that are definitely not able to map to anything.
Did you consider using verbal actions like Austin's performatives, like I excommunicate you, because your actions are verbal actions,
Mm-hmm.
and there are verbal actions in the world where somebody is excommunicated or made queen or whatever. That might be useful.
Thank you.
Any other questions? I had a quick question. Use the mic. I was wondering if you had any idea about the distribution of the actions in your corpus. So you had about 85 actions.
Mm-hmm.
It seems like my guess would be that there would be like a power law distribution.
Yeah.
Is that what you found as well?
Yeah, exactly. I mean, well, you can see the details in the paper.
Okay. Yeah.
But yeah, basically there is like a typical Thieves' law distribution. So, you will
the reason I was asking is that when you've got the recall at 1 and recall at 10, it would be interesting to see the most, a system that predicts, the most frequent 10 classes, how well that does.
Yeah, that's right. Now I could tell you that I think in most cases the most misclassified action was usually like a 1 frequent action. I don't remember now the exact number, but it was, that happened, yeah.
Excellent, thank you.
Thanks.
Let's thank the speaker once again.
Where's my adapter? Somebody get me.
Does somebody have Presla's adapter?
Okay, somebody has my adapter. Who spoke after me? The second one. This happened to me at a conference before. Okay.
I'll have to find him after the break.